In this one, let's review writing interval notation and then how to use that to solve an inequality, a quadratic inequality. So express the graphed inequality in interval notation, examples 1, 5, -5, 10, and so on. So what matters here is to observe that, for example, this here is an open circle and this is an open circle. That means that when you write the interval notation, you put -1, and next to the -1 you put a parentheses, you put a comma, and next to the +1 again you put a parentheses because it's an open circle. So that's the first one. That's the interval notation right here. Let's move on. That's all there is to it, nothing else really. The next one says, what's the interval representation from -4 to 6? Again, there's a difference here, which is above the -4 the dot is filled in, above the 6 the dot is filled in. And notice that it's shaded between them. That tells you it's a closed interval. So when you mark this one, for example, in the box, you would say -4. Next to the -4, you would put a bracket. The bracket corresponds to the fact that this is filled in. You put a comma, and then you put 6, and then you put a bracket next to the 6 to indicate that the 6 is also filled in. So -4, 6 brackets are on the values. Let's move on to the next one here. This one looks a little bit different, so this is going to require us to use a union operation. But when you do it, you just look at it from left to right. So notice over here is -infinity. You put a comma, you go up to -3. -infinity on the left side here, that's not a number but a concept, so it's always parentheses. The -3 above it has a hole, so that means you put a parentheses next to it. Then you jump over the gap to 4 on the right side. And again, above the 4 you have a hole, so you put parentheses this way. You put the starting value of 4, you put a comma, and then notice the arrow points to the right, so it's going to be positive infinity. The fact that there's a gap between these, that indicates you have to use U for union. So when you write the answer in the box, it looks like this. Over here, -infinity, comma, -3, parentheses, union, and then 4, comma, positive infinity, that way. So the gap, jumping over the gap, you indicate with the union operation U. So now that we have reviewed the basics of intervals of different kinds, let's solve an inequality. Many different kinds of inequalities are possible, so we'll just take a look at a simple inequality that looks like this. Let's see here. It says, solve the following inequality. X squared minus 3x plus 2 is less than 0. And then write the answer in interval notation. So keep that inequality in mind. We're going to solve it as follows, okay? So step 1 is, you have x squared minus 3x plus 2 is less than 0. So you factor on the left side. So it looks like this. To factor, you need two numbers that multiply to 2, and the same two numbers have to add up to -3. So you put your variables here. So again, so if two numbers that multiply to 2, and the same two numbers have to add up to -3. You can probably think of these, let's see here, 2 and 1. Well, 2 times 1 is 2, but 2 plus 1 is not -3. So you gotta adjust the signs the right way. Try negatives, for example. -2 times -1 is +2, that checks. -2 plus -1 is -3, that checks. That's how I know these are the correct signs with the 2 and the 1. At the next stage, you make a little number line, and you're going to have to test the inequality. So make a little number line. And the number line, you mark the roots. Remember, the roots are the opposites of the values you see in factored form. The opposite of -2 is +2. Okay? And then the opposite here of -1 is +1. And then what you do is you choose a sample value and then test it in the inequality. Either it makes the inequality true or not true. So for example, take a look. Keep in mind this inequality. I'm going to scroll up a little bit here and then zoom in so we can see things better. You can choose, for example, right here, x equals 0 as a test value because that is to the left of the 1. And you plug it into the inequality. So let's see here. I'm going to do that over here. Let me separate the work. I'm testing with x equals 0. So when I do that, I have 0. And you can use the factored form or you can use the original form. I'm going to use, for example, the original form. I have 0 squared minus 3 times 0 plus 2. Is that less than 0? We'll check it. 0 squared is 0. -3 times 0 is 0. Those two terms go away. And is 2 less than 0? That's false. Well, that tells you that the range to the left of 1 on the number line would not be part of the solution because the inequality is false. So then, for example, you can choose some other value in between them. Let's see here. So like 1.5, like that. So let's see here, x equals 1.5. I'm going to check with this value. You might want to now use, for example, the factored form, as long as obviously the factoring is correct. So I'm going to say here 1.5 minus 2, and this is now 1.5 minus 1 less than 0. I'm checking whether that is true or not. Well, 1.5 minus 2, what kind of number is that? That's a negative number. I don't even care about the number itself. I just care about the sign of the number. 1.5 minus 2, that's a negative number. 1.5 minus 1, well, what is that? That's a positive number. Well, think about it. A negative multiplied by a positive is negative. So that would be less than 0. This tells you the following, that all the values from 1 to 2, use only one sample value, but that means it's true for all the values between 1 and 2. I'm shading there between 1 and 2. All the values make the inequality true. And then if you want to be very careful, you can also check with, for example, x equals positive 3. I'm choosing this value right here as a sample value from the number line. So when I do that here, I might say the following. I'm going to plug 3 in. So I'm going to have 3 minus 2. I'm going to have then 3 minus 1. The question is, this less than 0? Well, work it out. 3 minus 2 is 1. 3 minus 1 is 2. 1 times 2 is 2. Is 2 less than 0? Well, that's clearly false. Okay? That tells you that to the right of the 2 on the number line, those values are not included. The middle, remember, was true. What happens at the 1 and the 2 themselves, where these are excluded, look back at the original inequality, it's got the less than symbol. You see this? It's got the less than symbol, which means the 1 and the 2, which are the roots, themselves are excluded. So that means the following. In the box, as the answer, you might type parentheses, 1, comma, 2, close parentheses. Just like that. Let's take a look at one more example. Solve the following quadratic inequality: x squared minus 5x plus 6 greater than 0. I have x squared minus 5x plus 6 greater than 0. So what you do, of course, is you factor on the left side. So you need two numbers that multiply to 6 and add up to negative 5. It's always the same thing here. So we'll have the following: minus 2 and minus 3. Negative 2 times negative 3, positive 6. Negative 2 plus negative 3, negative 5. Checks. This is greater than 0. You mark your number line. The opposites are the ones that go on the number line. So put positive 2 and then you put 3 positive right here. Let me erase that. I was meant to go in that. Put maybe holes above these at first. And I know there should be holes because you see how it says greater than strictly? Right here, you see this? It says greater than. So it means don't shade in the dots. If you had greater than or equal to, you would shade in the dots. They would be included in the solution, okay? So let's go and do some tests here just to see what solves this inequality. So for example, I'm going to choose at step 4, I'm doing my tests. First, I'm going to choose a value to the left of the 2. So I might choose 0 if possible. It's always easy. Plug it into the original. So 0 squared minus 5 times 0 plus 6 greater than 0. Well, this goes away. They're both 0. Is 6 greater than 0? That checks. That tells you that starting from the 2, you can shade to the left, okay? Because 0 is to the left of the 2. Then you repeat for the middle. Well, what's between, let's say, so choose 2.5, plug it into the factored form. Okay, so I'm testing now with 2.5, which is kind of in the middle right here, okay? So when I do that, I will have 2.5 minus 2. Let's see here, 2.5 minus 3. So 2.5 minus 2, that's a positive number, but 2.5 minus 3 is a negative number. Notice that I don't care about the values themselves, I care only about the signs, that's all. So here, is that greater than 0? This is what we are testing, remember, okay? The original inequality is greater than 0. A positive times a negative is not greater than 0. That tells you that it's false. Just like the one on the left side is true. So that means from 2 to positive 3, you don't shade that. Let's do one more on the side. So again, I'm going to choose 4 as my test value and just plug it into the inequality, see what you get, okay? So I'm going to use 4 minus 2, and then here I have 4 minus 3. Is that greater than or equal to 0? Well, 4 minus 2 is 2. 4 minus 1 is, 4 minus 3 is 1. This is 2 greater than 0, right? 2 times 1 is 2. So here, as you can see, it's true. That means everything to the right of the 3 over here, all of that would be shaded like that, okay? Everything is shaded in that direction. Which means when you enter this, it takes this form. You have to use the union symbol. Take a look. Over here I will say, let me grab a different ink. I will say Be careful now, because it's going to go from negative infinity, next to the negative infinity, parentheses, up to 2. Next to the 2 you put parentheses because the 2 is not included. Union. Then we zoom on the other side. You're going to put 3. Next to the 3, make sure you put parentheses. It's not included, comma, and then you're going to go towards positive infinity like this. And that then would be the solution. And that completes everything. Thanks so much. I'll see you in another video.